In this video, you will learn how to post-process the results from the solver. First, we will find the total drag on the car, create velocity contours and create velocity vectors. Then, we will also create path lines and animation to showcase the flow around the car. Find the drag on the car by clicking on the forces and let's select back wheel, fairing and the front wheel. We can see the total drag as highlighted. Create a velocity contour. Deselect global range. Select the symmetry and the fairing as the surface and click display. We can see the velocity distribution on the symmetry. Create a velocity magnitude vector and let's select symmetry as the surface. Deselect the global range and display the vectors. From this, we can see the flow reversals near the back of the car and the general flow direction around the car. Display the mesh as shown. Create path lines to visualize the flow characteristics around the wheels. Choose line from the surfaces. Let's choose the points around the wheel by right-clicking on two locations. And change the y-coordinates as we want the line to be raised up from the ground. Pick velocity from the options. Choose the line that was created. Change the number of the steps to 2000 to increase the line's length. We can see the path lines around the wheels. Create a scene by highlighting contour and path lines. Let's also create a mesh to display as shown. Display the scene created. This shows the velocity contour and the path lines. Now, we are taking our results to Cfd Post for further processing. Click File, Export to Cfd Post and highlight all the quantities. Write the post file to your preferred location. Cfd Post will open up automatically. Under Transform, apply reflection. Choose the method to be from the XY plane and apply. This will reflect the car along the XY plane. Create a pressure contour. Choose front wheel, fairing and back wheel from the list and make sure to hold Control when making the selections. Change the number of contours to 30. Change the transparency and render to 0.5 and deselect Show Contour Lines, and let's apply. Deselect the wireframe so we can only see the car. Create a line. Make sure to input the coordinates of the points as shown. Change the samples to 100 and click Apply. Create velocity streamlines and make sure it starts from the line we have created. Change reduction to reduction factor, leave it to 1. In your case, if there are too many streamlines, reduce the value to your liking. Change the range to local under color. Under symbols, Select the stream type to tubes, and change the width to 0.1. Hide the line. And let's create an animation. Select Keyframe Animation. Let's record the current keyframe and change the coordinates of the lines as shown. Click Apply and record this keyframe. Change the number of frames to 20 for both the keyframes created. Click the play button to preview the animation. Select Save Movie to save the animation as a video. Cfd Post has more options to improve the animation speed and quality. Play around with the settings until you are happy with the animation and export it. This is the final animation of the streamlines. Thank you for watching, and this concludes the video series on the aerodynamics of a solar car.